Hello students, in this video we'll discuss reduced row echelon form. So we say that a matrix is in row echelon form. We're going to abbreviate this REF. And echelon just means it looks like a step. So step-like matrices, if three things are true. If, number one, first is that all entirely zero rows are placed on the bottom of the matrix. So put those in the last rows. So the zero rows, the rows that are entirely zeros, are always put on the very, very bottom of the matrix. Okay, that's the first step in the echelon form. Number two is that if the first entry in a row, so if I look at a row, I look at the first non-zero entry, is called the lead coefficient. And the lead coefficient for any row must be to the right or farther down the columns than the ones above it, right? So the lead coefficient are always to the right of lead coefficients above it. Okay, that's the step structure. Okay, in other words, if I give you a lead coefficient, then if I'm over here, so in other words, if we're over here, if I have a coefficient, let's say a 5 over here, and that was my lead coefficient in this row, then the next lead coefficient over here had to be above it, right? So in other words, that had to be like maybe like a 1 over there, right? Maybe like a 0 to 0. But in other words, we get this sort of this step-like structure over here. So that's like sort of the step component of this. And then the third condition is that there's always zeros below the lead coefficient. There are always zeros. There are only zeros below lead coefficients. And furthermore, I can call something that is a special condition if these three conditions specify what reduced row echelon form is. If in addition, if also, for that says there are only zeros above the lead coefficient, if this extra condition is true, then we say it's reduced row echelon form. Okay, excellent. So let's look at some examples of these echelon matrices, okay? So I'm going to draw a matrix over here. So here's going to be a 1, then a 2, then a 3, then a 4, then a 5, then a 0, then a 0, then a 5, then a 6, then a 7, then a 0, then a 0, then a 0, then a 0, then a 1. This row is a reduced, this is just a row echelon form matrix. This is a row echelon form matrix. Let's check all the conditions. Well, first of all, there's no rows that are entirely zero, so there's nothing to worry about for that first condition. It's automatically, it's vacuously satisfied. It says the first non-zero entry is called lead coefficient. So what are my lead coefficients over here? Let's circle them. So the lead coefficients over here are 1, 5, and 1. So these are the lead coefficients. Those are the lead coefficients. The lead coefficients are always to the right of lead coefficients above it. So here's 5 as lead coefficient, and that's definitely to the right of course, there's some funny mirroring that's going on over here, right? So from the perspective of the light board, it's going to be mirrored, right? So from your perspective, you'll see that 5 is definitely to the right of 1. Excellent. And this 1 over here is a lead coefficient. Okay, and it's to the what? It's to the right of 5. Excellent. However, this matrix, and of course, what's the last condition? There's only zeros below the lead coefficient, so I have a 0, 0 over here, that works, and a 0 over here, that works, and it's vacuously true over here. So this is definitely a row echelon form matrix. It's not reduced row echelon because I have what? Above the lead coefficients, I have non-zero numbers over here, so it's not a what? It's not a reduced row echelon form. But we can certainly see sort of the step structure over here. So there's a sort of this step matrix that looks like this. I go from the lead coefficient, then I go down, I step down to the next lead coefficient, I step down to the lead coefficient. So we sort of see this step-like structure over here in my reduced row echelon matrix. Let's look at another example. Here's an example like this. Let's do this one over here. Let's do 1, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so I have 6 rows over here. Then I'm going to do a 3 and then a 0, 0. Then I'm going to do a 0 and then a 1 and then a 0. And then let's put a 0, 0 over here and then a 0 over here. And then a 0, 0, 1. And then a 0, 0, and then a 3 over here, okay? So let's check and see if this row is in row echelon form or reduced row echelon form, okay? So the first condition, all the entirely 0 rows are at the very bottom, okay? So this last row over here is entirely zeros. That's good. The 0 is at the bottom. And then it says, let's look at our lead coefficient. What are our lead coefficients over here? Our lead coefficients are the first non-zero entry in a row. So my lead coefficient over here, so let's look at our lead coefficients. So the 1, and the 1 are lead coefficients, right? And we should specify over here, we would like the lead coefficients to be equal to what? By sort of multiplying them, we can say that this in row echelon form, but oftentimes you specify you want the lead coefficients to be equal to 1 as well, right? So row echelon form is also specified. There's only, and the lead coefficient should be equal to what? Let's say that the lead coefficients have to be equal to 1 too, just to make sure we're with standard conventions sometimes in most other textbooks, okay? Of course, it's sort of immaterial because what I can do in that situation is I can always arrange it so that they're 1 by sort of scaling the equation using elementary row operations. Great. Now below, the lead coefficients are all zeros. That's great. And now above the lead coefficients are what? Above the lead coefficients are all zeros. So this is a reduced row echelon form over here. All right. Let's look at one more example. Here's the last example. 1 and then a 2, 3, 4, 5, 0, and then a 0, 0, 0, 0, 0, 1. Okay? This matrix over here, let's see if it's in reduced row echelon form, right? So what are my lead coefficients? My lead coefficient over here is 1, and my lead coefficient over here is 1. Okay, that's great. Those are my lead coefficients. There's no 0 rows to worry about over here. And now below every lead coefficient, there's only zeros, and above every lead coefficient, there are zeros. So this matrix over here is in reduced row echelon form, right? And so in further videos, what we're going to see is using a method called Gaussian elimination. It's attributed to Gauss, but it's actually known way before Gauss to Chinese mathematicians. It was known way before that time that if you can take any matrix and by performing elementary row operations, you can put a matrix into this reduced row echelon form. And we'll see how that's valuable for finding if a system is consistent or inconsistent. Thank you very much.